All right, thanks for coming down today to hear us talk. We're going to talk about some of the ways that we accelerate artificial intelligence solutions with the Rakuten Cloud Platform and Cloud Platform Suite. All right, so we'll start off with this solution. So one of the things that we are seeing and why we have this particular drawing here is we're seeing the proliferation of AI to the edge. How do I make intelligent decisions at the edge? How do I make it relevant using data that's actually at this edge, right? You know, do I need to go back up to the cloud if I'm using my current inventory? Which is a big thing for retail. So a big piece is I need to make decisions at the edge. And I also wanted to start with this particular diagram because it helps to show the complexity of AI in terms of geography and infrastructure. There's a lot of different challenges. Before I can run any AI or ML workload, I need to make sure a lot of things are in place. I need to have physical infrastructure, like we're showing things there. On top of the physical infrastructure, as we know, you need something like Kubernetes. You need a cloud platform to actually run it. I need to make sure that my physical infrastructure has the right software, it has the right hardware, it has the software security patches, and I need to do the same for my cloud platform. And then I'm going to deploy service, and a service isn't just one network function or one application, it's a concert or a symphony of multiple applications running together. That's just to get it off the ground, because where the real challenge there is then in the operations. So when we're thinking about AI, we want to think about edge, and we don't want to just think about the AI application itself. It's about all of these other things that need to be done just to get them off the ground and just to manage them. All right. So at a high level, and you're not here for a product pitch, so I'm not going to go too deeply, but the main suite of products that we sell in our business unit that does the cloud are, we have a cloud-native platform, which we have incredible automation and policy-driven automation there. It's not just about things. When people talk about policy, they talk about NUMA nodes. They talk about CPU and GPU, but there's a lot more to it than that. I'm deploying a service. I'm not just deploying one app on one node. I may have certain applications that need affinity or anti-affinity towards others. It may want to use a different database for one than another. And if I'm going to have any kind of backup and recovery, we're talking about AML workloads, I may need to make sure that I'm, again, on the right hardware. So all of these different things that we talked about on the previous slide, we must have policies where I can define them on my cloud platform. So when you perform any kind of backup, snapshot, any kind of recovery, I'm actually not just looking at the storage, I'm looking at the state of the entire application and all of the Kubernetes config in itself. And why is that important? Well, back in the day, when we just had virtual machines, that wasn't that important. I just loaded up my storage, I loaded up my virtual machines, and I hit the go button and I was done. But under the covers of Kubernetes, I have multiple containers, I have multiple networks, right? I have different storage configurations. So therefore, when I do a backup or snapshot, I don't need to just snapshot my storage at a single point in time, but I need to snapshot all of this. And if that doesn't resonate, then you're lucky, because that never means you got hit with the problem of having to do a recovery where you have up-to-date data, but an older day 1 or even a day 10 config. You have to go and reconfigure everything. But when you do backup, snapshots, clones on the entire application and storage construct, you just press a button and it's done. And then you have the policy that I talked about here in the cloud-native platform that says, I'm going to find the right place to put my storage, the right place to put my application, the right kinds of networking to put in place, and it's instantly done. Last but not least, we have our Rakuten Cloud Native Orchestrator. All of the things on the previous slide, from the bare metal to the services, can be orchestrated in a single workflow. You don't need multiple tools. You just have one context-aware multi-domain workflow. So when I need to deploy these things in the core, the near edge or the far edge, again, I can just press a button and it's done. You know, I see a lot of people using a tagline we've had around here that says, stuff that used to take a long time now takes a short time. Yeah, but you know, it's very apropos. Things that used to take days now take minutes. Right? And all of this needs to be in place so you can be successful throughout the entire life cycle management of your AI workflow. Right? So underneath the covers, underneath the orchestration, underneath the policy, we have key technologies. Things that help you unlock your GPUs efficiently, right? We have high-speed storage to feed those hungry, fast GPUs, right? We have advanced networking, because again, if maybe we get into a multi-tenant situation, everybody may need their own network. I may need overlays, I may need underlays to service different parts of that AI pipeline. As we talked about earlier, I need advanced workload placement and storage placement, because when I want to move, I want to migrate, I want to clone, I want to recover, I don't want to have to go and figure all this stuff out. I need the policy in there. With AI, and you look around with everybody here, some of the big hyperscalers, or even in larger businesses, there's a question of multi-tenancy. Very, very key, because you don't want one customer or one tenant clobbering another tenant. And as we've talked before, I should be able to orchestrate anything, anytime, anywhere. And although you always tell your kids something might not be worth doing unless it's hard, orchestration's the other way. If it's hard, you're probably doing something wrong and you shouldn't do it that way. So we'll talk about these as we move forward. So, we have support for NVIDIA GPUs, we do slicing, we do virtual GPUs, and we can use that to accelerate AI training, and we can use it to, enhance performance of the overall solution. So any solution with AI, you should see, should have a, not just GPU support, but automation for that support and the way we talk about it. Because again, it's not just the fact that you have GPUs, it's how you manage them and how you use them and how you automate them. Next, storage and workload placement. And this is an example of just something with NUMA involved. And a while back, this was good. If I just had an application that I'm deploying NUMA and being able to say I wanted a sibling pair, or I wanted an underlay or an overlay, I wanted to make sure I use these particular cores, that was good enough. Really important under the cover, but we need more flexibility like that. It's not just deploying an application on a node. With AI, it's deploying an entire application pipeline with many supporting network functions across numerous nodes. So how do I find the right nodes without having to hunt and hard code those things? If you're hard coding, then you don't have policy-driven automation or policy-driven orchestration. High performance storage, something that sometimes gets overlooked. Now we have a software-defined storage solution, which allows you to aggregate resource pools of hyper-converged nodes, etc. But you need the trinity of block, file, and storage, because depending on whether you're storing models, or whether you're backing up it at the core, or you're running a high-speed database, you're going to have different needs for those. And you need something that's unified under the cover, that plays nicely into that all application awareness, application-aware storage, where I'm manipulating the entire application storage construct. So it's not just about file storage. Next, granular multi-tenancy. So some people say, well, I really don't care about multi-tenancy until they get hit with it. I've worked at numerous companies before where if I wanted to set up a sandbox, I had to fill out a services now ticket, I had to wait for somebody, and they had to custom build an environment for me. And that was a lot of work. You need a multi-tenancy that's, simple GUI drop and drag that says, all right, here's a tenant. Here's the policy for their resource pool. We'll let them grab these resources. Here's if you want to restrict their networking domain or leave it wide open, it can do that. But what's better than that? Because that's still an example that says Brooke has to go somewhere and he has to set something up. This all needs to be in a self-service portal that I have policies behind it. I should not have to fill out a services now ticket. I should not have to wait to do it. I should have a portal that has the intelligence to manage multiple tenants, multiple clusters at a node resource level, at a storage resource level, with networking flexibility. And I should be able to say any user in any tenant, I'll give them roles-based access, and there should not be a single thing that I can do here that I couldn't map individually to the tenant if I want to. It's, the days of, you have read access, you have write access, you have admin access. I mean, that's slow and old like me. We need something much younger, much fresher and nimbler, where I can, again, give people multi-tenant self-service access exactly how they need it, not a bit more and not a bit less. Advanced networking. I put this one after that because one of the things that people sometimes overlook is the importance of a, granular or complex made easy networking. Because when you look at what we just talked about with multiple tenants, everybody is remote and everybody is communicating remotely. And when we're communicating remotely, we're talking over a network, all right? So I need to use, standard CNI type of technology. I need to make sure that I have persistent IP, right? Because when you look at all of these AI applications and pipelines, they're stateful applications. All right, so a stateful application means that if I crash or I scale or I come back up, I need to come back in the proper state. My data must persist as is. Right, so I need to make sure that I have the IP persistency for that. I may want to have underlays, right, because some people, for performance characteristics or sometimes for security characteristics, I may need to give someone their own specific underlay for that. Of course, we want overlays, and if I need performance, I want to make sure that I can have NIC pairs, so I can get more out of the networking. IPv4, v6 is, now table stakes as well as both internal and external load balancing. So we need to have this under the covers, so when we go to those really easy to use multi-tenant pools, everything works as people expect it to work. And last but not least, let's talk about orchestration, monitoring, and logging. And I'll repeat what I said earlier. You won't tell your kids this, but if it's hard, don't do it because you probably can't scale. If you're working with 20 tools across multiple teams, you probably can't pull it off. You want a multi-domain orchestrator that handles everything, every location, every type of node, multiple cloud platforms. You shouldn't just have to use ours. Multiple storage solutions. You shouldn't just have to use ours. Any application, and I should be able to click a button and it should happen instantaneously. On top of that, just deploying it is the very beginning of the game. Back in the days of OpenStack and people were going towards virtualization, I saw people have a lot of issues. They so over-rotated on day one and getting things deployed, they had no idea. They made these huge messes. They couldn't do things on day 2 through day 1,000. So you need to make sure you set up the monitoring and logging, and you have all those cool policies we talked about. Because if you're hunting and hard coding to fix something, or to scale, or to add, or to move, then you're doing it the hard way, you're doing it the wrong way. And of course, everything works in a multi-tenant environment here. So thank you very much for your time today. So when we think about AI applications, it's not just about models and speed. It's how are you going to deploy it, how are you going to do it efficiently, how are you going to make it error-free, and how are you going to make it easy. Thank you.